Hi, now I'm gonna solve number 461 Hamming distance. So here we have two integers which we'll represent in binary and then find the number of different bits. So we'll start with it. I'll solve it in Java, and we'll start with the long way, which everyone can understand. I'll create a new project. I'll select the public static void main so we can try it, and I'm gonna call it Hamming distance. So I'll take this function, I'll copy it just to keep the name the same. I'll press Ctrl Shift F to keep everything tidy, and I'll change this to static just so we have no problem in Eclipse. The original idea here is to represent each number in binary, and then afterward count the number of different bits. So to try it, I'll just type here sysout and Ctrl space to change it to system out print line, and select Hamming distance and type in two integers to try them. Now here I'll change the first integer into a string, into a binary string. So I'll call this one x string, and I'll use the method that's built in here to change it to string. So this is x, and I have similarly a y string, which is integer to binary string y. So now I have two numbers that are represented in binary. Just to keep track of them, I'll print them. So again, sysout Ctrl space, and here x string plus y string, so we can see what's happening. And I'll type return 0, and that's just temporary, it's for the moment. So let's run our program, and here we see the two binary representations. I want to count the number of different bits, so I'll create an integer that has the role of counting bits. So this is different bits, and I'll initialize it to 0. I'll also take two variables, x size, which is the size of the binary string for x, and so it's x string dot length, and I have y size, which is the same for the y string. Now I have to consider different possibilities. So this is x, this is y, and let's say I have 1 0 1 1 0, and here I have 1 0 1. So these are two of different sizes, and I have to deal with this case in a different way than this case. So if x is shorter than y, I need to work in a different way. So for the first part in my algorithm, I'm gonna compare these common parts. So here I have this one as different. So I have a difference here, and here I have a difference. And then for the rest, I'm gonna count the number of ones in them. So this is supposedly padded with zeros. So this is 0, there's no difference. I have a difference here. So for my first part, again, I'm gonna see the similar, I'm gonna compare the common part, and then in the left part, I'm gonna count the number of ones. So let's start with this. Now we'll consider the first case, which is if the size of y is less than that of x. And here I'll start with the common part as I explained. So we'll start with int I equals 0 till y size. Now this is 0 indexed again. I guess most of you know this. I'm gonna take the shorter size and I'm gonna work backwards. So this is the first thing that I'll process, and I'll start here, and then I'll move to this one and this one. So I'll take individual characters, and here I'll take if x string dot char at, and I'm going backwards, so I can go from x size minus 1 minus I, and I starts at 0. So this, if we number the indexes, this is 0, 1, 2, 3, 4, and this has a total size of 5. So this is 5 minus 1 for I equals 0. This is 5 minus 1 minus I equal 1. 5 minus 1 minus I equal 2. So I'll take this one. If it's different than y string dot char at, again y size minus 1 minus I. In this case, I'm gonna increase the number of different bits, so different bits plus plus. Now what will I do with the rest? How am I gonna deal with the rest? So I dealt with those. Let's grade them out. I still have these two. I can go from 0 till 1. Now 1 is the difference between x size and y size, since x size is the greater value. So again, here I can go for int I equals 0, I less than x size minus y size, I plus plus. So x size is 5, y size is 3. The difference between them is 2, and here I took less than 2. We need to fix these brackets, and let's continue. Here in this case, I'm gonna take if x string dot char at I is equal to 1. This is a character, so I put these marks. And in this case, I'm gonna increase the number of different bits. If it's 0, the bits are the same. I don't need to increase it. If it's 1, then the bits are different, and I'll increase it. Now we consider the case where y size is less than x size. We still have the else case. So I'm gonna type else, and this will cover whether they're equal in size or whether x size is less. We're dealing with this one, and it's either this way or maybe this way. And in this case, all of these are common, yet we'll get this covered. So we'll start with the same logic. I'm gonna copy these. For int I equals 0 till I less than x size this time, we have if x string, and we're gonna traverse it backward, the character in x string is different from that in y string, we're gonna increase the number of different bits. That's not gonna change. Yet here, it's the difference between y and x instead of x and y, since y is the greater or equal. And in that case, if y string is equal to 1, we're gonna increase the number of different bits. So here, if we have a 1 here, we're gonna increase the number of different bits. Now, what if these two are equal? If these two are equal, it will start at I equals 0 and till I less than 0. So that's not gonna work. It won't enter the loop. So we can try this, and here instead of returning 0, we have to return different bits. And let's run it. We see we have 2 different bits here. Let's try another case. Let's try the one in the example, and here we have 1 and 4. So that's 1, that's 4. And if we run it, we have the answer 2. This is 2 as well. So I'm gonna copy this code and paste it here. This is not the optimized code again, but this is how the algorithm is working. I'm gonna run it, make sure that it's okay. And I'm gonna comment out the sysout and submit it afterward. I got this result. It takes 1 milliseconds to run. Now I can make a shorter version of this, and with a shorter version, I'll write less lines, it'll execute faster, and I have less to go wrong. So to write the shorter version, I'm gonna keep the main, I'm gonna erase everything else. I need the different bits, so I'll have, again, different bits. It's an integer. And I'm gonna do it using a XOR operation. Let's take a quick overview over the XOR and why I use it. If I have a 0 and a 0, this will return a 0. The XOR is exclusive OR. If I have one bit set and the other isn't, I'll have a result. This will result in 1. Again, if I have 1 here and 0 here, I'll get 1. And if the two are set, if the two are 1, I'll get a 0. So if I XOR these, let's see here, I'll apply XOR to this one. This one and this one are different, so I'll get 1. These are the same. This will result in a 0. These are the same. It will result in a 0. These are different, and these are the same. So that's the result. They will add up to 2. So let's do this bitwise, and I'm gonna use the XOR operator here. And I can store the result in a new integer. Let's call it z, and it's x XOR y. The XOR operator is this shift 6, which we use to indicate the power symbol. And I stored it in a new variable, and even better, since I don't need x anymore, I can store it in x itself. So x now holds the result of XORing x and y, but it's still a decimal, so I need to change it to binary, to a binary representation. So I'll take a string, I'll call it x string, and here I'll use integer.toBinary, and what I'm gonna change to binary is x. Let's print this just so you can see the result. And I'll add a return 0, which I'll change later just to run the program. And we can see here it's representing it as 101. Let's count the number of ones. So I'm gonna change. I have now a binary string, and I'm gonna count the number of ones in it. So for int I equals 0, I less than x string dot length I plus plus. And here I'll take each character. So x string, I'll get the character carat I, and if it's equal to 1, I'll increase different bits. And at the end, I'm gonna return different bits. So I don't need this one anymore, and let's fix this to string. And if I run it, I'll get 2. So let's replace our code with this one. And this is much shorter. If I run my code and submit it, I'll get a better result. And now I know the timing here isn't very precise on Leetcode, but the result is much better now, and we have less lines, we have less to go wrong. Yet I can make this even better, and I can count the number of ones in a binary representation. I can make this one even better by deleting this line and counting the number of bits using a built-in function. So just a reminder here, If I compare these, I have this representation, and here I have two set bits. There's a function that would count these for me, so I can here type different bits equal integer dot count bit count, and I'm gonna count the bits in X since it holds my XOR value, and return different bits. If I run this, this will result in 2. I can make it even cleaner by deleting this and deleting this and returning this one directly. Let's copy this one. Let's replace these with it. So this is what we have, and I'm gonna run it and submit. And this is a very short way to achieve the task.